All right, so we are on chapter 4, section 2, and we're going to talk about the simplest kinds of organic compounds. And so those, when we say simple, we mean only carbon and hydrogen. Those are the only two atoms that are going to be in the entire formula. And so we call these compounds alkanes. And I like to remember this because A is the beginning of the alphabet. So alkane, we're going to find out alkenes, alkynes. We're going to talk about some other ones. But the simplest, right, starts at the beginning of the alphabet. And so we have alkanes as our simplest organic compound. So alkanes, only carbon and hydrogen, nothing else. And we say that alkanes are saturated hydrocarbons. And it sounds complex, but it's not. Think about hydro. Hydro is telling you that you have hydrogen. Carbo is telling you you have carbon. So hydrocarbon tells you that you have a molecule that's only hydrogen and carbon. What does this saturated refer to? Well, saturated is telling you that this entire molecule, all the carbons in this molecule are covered. They are just saturated in hydrogen atoms. So if you have carbons, say you have a chain of 3 carbons, and I'm going to saturate this. I am going to put as many hydrogen, let's see if I can move it. I don't know, I don't really have room anywhere. If I'm going to cover this carbon chain in hydrogens, give it the maximum number of hydrogens, right? What I'm going to do is I'm going to, right, give them as many hydrogens as possible. These are all hydrogen atoms that are going to be bound to the carbon. So this is an example of a saturated compound. Something that's unsaturated, you could have, let's say, a double bond between one of the carbons or 2 double bonds, right? If that happened, how many hydrogens could you put? Well, you can't put anything around that central carbon because this middle carbon has 4 bonds. It's completed as its octet. And then the 2 on the end can only take 2 hydrogens. So which one has more hydrogens? Right here, our saturated molecule. So if it is saturated, this one is saturated, then it's telling you that you have the maximum number of hydrogens on it, which saturate it. So the only way to get a saturated compound is to have compounds that only contain single bonds, right? So saturated compounds only have single bonds. If it's unsaturated, you're gonna have double bonds, triple bonds, all that kind of stuff. So alkane is simple, only single bonds. Simple, single bonds. Okay. All right. So we call these, the simplest form of alkanes are straight chain alkanes. They're carbon attached to a carbon, attached to a carbon, attached to a carbon. It's just a line of carbons. And so they can vary only in length. It's super simple. And so we give the compound its name based on the number of carbons in the chain. So remember how we named covalent compounds and we use those prefixes? We're going to do a similar. The first 4 alkanes are weirdly named. They're historical. They don't actually have to do with the number. Remember how we had like mono and di, tri. It would make sense, but we don't use them. After 4, then 5 or more, we're going to pick up those Greek prefixes that we've used in the past. And then every alkane is going to end in ane, and that's how we know it's an alkane. So let me show you some examples, and then we're going to come back to that slide. So our 4 weird ones, 1, 2, 3, 4, are methane, ethane, propane, and butane. The 5 through 10 are the same prefixes you had to learn for covalent compounds, so those shouldn't be bad. But how do you remember the first 4? This is how I remember the first 4. It's kind of a silly little mnemonic device, but it works. I say me eat peanut butter. This is how I remember it. So methane, ethane, propane, butane. Me eat peanut butter. it helps you remember the first 4, okay? And then the rest of them you'll remember from your covalent compounds. So when we look at the number of carbon atoms and we know it's saturated, what we can do is we can look at the number of carbon atoms and relate that to the number of hydrogen atoms that have to be in the molecule. So if you take, for example, ethane, C2H6, if we have 2 carbon atoms, how do we know how many hydrogens are going to be attached to those carbons? Well, we can kind of actually use a formula. And we can say, well, for every carbon atom, right? So for however many number of carbon atoms, if I multiply that number times 2, and then I take that number and I add 2 more hydrogens, I'm going to get my number of hydrogens. So let's see if that works. If I have 2 carbon atoms, if I want to know how many hydrogen atoms, I'm going to take my 2 carbons times 2, and then I'm going to add 2. So 2 times 2 is 4, plus 2 is 6. And that's exactly what I have, 6 hydrogen atoms. That is going to work for all of the alkanes. So it's super important that you recognize that. So it works even in the big ones, right? So let's say C10H12. How many carbon atoms do I have? Here I have 10. So I'm going to say 10 times 2, right? Plus 2 more. So 10 times 2 is 20, plus 2 is 22 hydrogen atoms. And that's exactly what I have. So we represent that kind of with a formula. So our formula for alkanes is however many carbon atoms we have is N. So N is equal to number of carbon atoms. That's N. H is going to be 2 times N plus 2. So it's the same formula that we just showed. That you have to remember. You have to remember that. So I'm going to put a big star there. You have to know this. Okay? All right. So the next little more complicated form of alkanes is when we have them forming a ring, and we call that cycloalkanes. So like you're going to go on a bicycle, right? It's going to have a circle. Everything's going to meet. And so we call these ring forms. So if you think about a ring form, we always want to indicate in a name that it's a ring. So we're going to put on the front of it cyclo. So when we have on the front cyclo, that's going to tell us it's a ring. And so the simplest form of a cycloalkane is cyclopropane. So remember, me eat peanut butter. So cyclo tells us it's a ring. Prop tells us that we have 3 carbons. So this is 3 carbons. And then ane, A-N-E, tells us that we're saturated. So we have only single bonds, only single bonds. So you can look at the name and get a lot of information out. You see a lot of 5 and 6 carbon rings in nature. They're super, super common. And so it's important to be able to recognize them and name them. So here are some examples, right? We have cyclopropane, cyclobutane, cyclopentane, cyclohexane. And if you look at the structural formula, right? We have, let's look at cyclobutane. We have C4H8. In order to make this happen, what if you were trying to figure out, is this a cycloalkane or an alkane? Well, if I draw C4, if I give myself 4 carbons, right? And I know it's an ane, so I'm going to put a single bond in there, and I have 8 hydrogens. Well, if I try to put 8 hydrogens, if I do this, okay, that's 3, 4, 5, 6, 7, 8. I used up all my hydrogens. Well, that's no good, right? This is an incomplete structure. I can't add more hydrogens because this is my formula. So how am I going to give everybody a complete octet? Well, I'm going to take one of these hydrogens. Whoa. I'm going to take one of these hydrogens from over here, and I'm going to put it on this carbon. And I'm actually going to link the first carbon to the last carbon. But that's not how it actually happens in nature, right? You don't have one bond that's super long and then some other little tiny bonds. And so in order to draw this properly in the way that it actually looks like in nature, is that you draw it as kind of a square so that all your bonds have about the same length. So that looks, it's a ring. It's not a circle, but it's a ring of carbons. And the ring can have a different number of carbons, which gives it a different three-dimensional shape. So then if I add hydrogens, that's 2, 4, 6, 8. So what you notice when you draw your cycloalkanes is that these cycloalkanes are going to have 2 hydrogens for every carbon. So if you wanted to pick a formula, right? If we want to pick a formula, oh, and I didn't put it here. Okay, they don't have it here. Is that I'm going to say, here's my carbon. Whatever my number of carbons is, my hydrogens are going to be 2 times that number of carbons. And it works for every single cycloalkanes. So this is cyclo. Excuse me. So we have cycloalkanes are always going to be CN, H2N. So when you're doing this and you're only given a molecular formula, you can tell the difference between an alkane and a cycloalkane. So here's cyclo, right? And then we know our alkane, our plain old saturated alkane, is going to be CnH2n plus 2. So if you see it's more than double, this is going to be a straight chain. If you see it's simply doubled, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, 6 times 2 is 12. That is a dead giveaway that it is a cycloalkane. Okay? Make sure you can recognize that. So, because alkanes are just carbon and hydrogen, and we've talked about carbon and hydrogen, we talked about electronegativity in the last chapter, that their electronegativity values are so close to one another that basically they share very equally. They're good siblings, right? They share with each other evenly and equally. And so because the electron is shared equally, there's no partial positive or partial negative charge. And so these are non-polar compounds, right? Remember how we did that in the last chapter? We identified if a compound was polar or non-polar based on the bonds and the three-dimensional structure. Well, we're saying that all the bonds in an alkane, whether it's a cycloalkane or a straight chain alkane, are non-polar. So if the bonds are non-polar, the molecule must be non-polar. So regardless of their shape, all alkanes are non-polar. All alkanes are non-polar. And this really affects the behavior of these compounds in an aqueous system, right? They're non-polar, they don't really want to interact with water, and so they're going to behave in certain ways. And we're going to talk kind of in a little detail about how that works. Now, alkanes are super important to us, very, very important to us. They're not very reactive in terms of water, but they react really well with oxygen. And when they react with oxygen, you have combustion. So guess what you put in your car to get to school? You put an alkane in your car. You put a hydrocarbon. When you combust a hydrocarbon, if it's completely combusted, then all you're going to get is carbon dioxide and water. But the gasoline that we use is not a complete combustion. And so we do have other things being produced. And so scientists are actually looking for a way to have a cleaner combustion reaction and to find a new kind of hydrocarbon fuel that's going to replace our fossil fuels, because our fossil fuels don't burn cleanly. We have some other waste products that gunk up our environment and everything, right? Okay, so these are our commonly formed alkanes that we use. So if you have a barbecue pit, right, you probably use propane, right? That's propane gas. Methane is natural gas. So methane, like, you know, cow farts, methane, that's CH4. Propane is what you put in your barbecue pit to run it. What do you put in your car? You actually put isooctane. So there are 8 carbons. We call it iso because it's not a perfect straight chain. It's actually branched. And so that's what the iso comes from. But you have 8 carbons and 18 hydrogens. So it's all saturated. Diesel fuel is hexadecane, right? So all of these are alkanes, and they're super important, and we use them every single day. Super, super important. So now we're going to switch gears and we're going to go do some problems. Let me see if I can pause. All right, so here are our alkanes, and I went ahead and put in the table for the straight chain alkanes, and I put in the table for the cycloalkanes, just so that you kind of have it all in one place. I thought it was kind of nice. So remember that our alkanes are our fossil fuels, and if we want to remember our first 4 weird alkanes, we want me, eat, peanut, butter. And so that is methane, ethane, propane, butane. Okay, so those are our common ones. And then we're going to use our normal prefixes after that. So remember, in our alkanes, right, we only have single bonds for our carbon, right? Carbon, let's say carbon and hydrogens, and we only have single bonds, right? So we're completely saturated. And what's our formula? CnH2n plus 2. So however many carbons you have, you want to know how many hydrogens, you multiply by 2, you add 2. Okay. And then remember, your formula for a cycloalkane is different. However many carbons you have, if you want to know your hydrogens, you just multiply by 2. Okay. So remember those formulas. It's going to be really, really important. Name the straight chain alkanes or cycloalkanes whose structure or formula is shown. All right, so in order to do this, you want to count your carbons. Sometimes, like B, it's super easy. So if you have B, right, I know that I have 6 carbons. So my 6 carbons is going to be hex, right? Hex. If you look at that formula, what formula matches that? Is it my number of hydrogens is times 2 plus 2, or is it just times 2? This one actually fits the just 2, right? Just times 2. So CnH2n. So is that a cycloalkane or an alkane? It is a cycloalkane. So we need to insert our cyclo. So this is going to be cyclohexane. If you can match it to one of those 2 formulas, you can name it. Well, let's do A. Let's do A. So I'm going to count 1, 2, 3, 4, 5 carbons. Now they're telling me right here, right now, that it's not a ring. So this is not cyclo. So this is a regular straight chain alkane. It's showing me that with my diagram here, because otherwise it would have to be connected. So like A and B, I know we're going to be straight chains. So if I have 6, no, I don't have 6, I have 5. If I have 5 carbons, that is going to be pent. And then it's a straight chain and it's saturated with hydrogens, right? Because I see every carbon that has to be single bonds. So that's pentane. So that's pentane. C, let's look at C. I'm going to count my carbons. 1, 2, 3, 4, 5, 6, 7. 7 is hept. GP hept. And I can see that it's not a cyclo, so it's not a cycloalkane, it's not a ring, heptane. Okay, let's do the next one. Write the condensed structure for the straight chain alkane shown. So this one I didn't have to worry about it. I'm told these are straight chains. So what does hept mean? Hept tells me I have 7 carbons. What does meth tells me? Remember, that's me eat peanut butter. So me is 1. And decane, like a decade, is 10. Okay, so here we're gonna do the condensed structure. So when we write the condensed structure, if we come up here, this one was an example of a condensed structure. This is an example of a molecular structure, and this one is an example of our skeleton structure. So make sure you know the difference between a condensed, a molecular, and a skeleton. Okay, make sure you can recognize that and know what those are. All right, heptane, let's do A first. I need 7 carbons. So I'm gonna do 1, 2, 3, 4, 5, 6, 7 carbons. How do I know how many hydrogens to attach to each carbon? You need to look at how many bonds are gonna be to each carbon. So my first carbon, all I have is a single bond to this carbon here. But this is a condensed structure and I'm not gonna show bonds. I'm just gonna write my atoms in. So I know I have to have hydrogen. I'm gonna have to have 3 hydrogens to give carbon those 4 bonds or that complete octet that it wants. Now that second carbon is attached to the first carbon and to the next carbon. So this is gonna be a CH2. Same thing with the next one, CH2, 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 CH2. When we get to the end, this one only has 1 bond. So in order to complete its octet, we're gonna wanna give it 3 hydrogens. So that's A, heptane. Okay, methane, oh, this one's so nice and easy, right? Methane is only 1 carbon. How are you gonna give carbon a complete octet? Saturate it with hydrogens, you need 4, right? CH4. Okay, decane. Decane is 10. Ooh, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So whenever you do this, a really easy thing to know, if this is a straight chain alkane, only for straight chain alkanes, you just look at the carbons on the ends. These are going to be 3s, carbon on the end, CH3, and then everything else has to be a CH2 because we don't have any branches. So you can just go ahead and write CH2 for everything else. CH2, 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 and that's it. All right, let's see. Here we go. Write the skeletal structure. So remember, skeletal structure is that bare bones and it's just the sticks. So just sticks, right? And I'm gonna add to something on here. I want you to also name it, okay? We're gonna draw the name and we're gonna write the name and we're gonna draw the skeletal structure. Okay, so C6H12. What do you notice about the formula for this? However many carbons I have, my hydrogens, all I did was double it. So what must this be? It must be a cyclo. Now I have 6 carbons. 6 means hex. So I'm told it's an alkane or a cycloalkane, right? So it must be hexane. So cyclohexane. If you name it, it'll help you to draw the structure, right? So here's A. I'm going to draw A. I want 6 carbons and I want them in a ring structure, but I only want them in a skeleton. I don't want to draw the atoms. So remember, a skeletal is just sticks. So in order to do that, what you do is this kind of hexagon, right? So then I have 1, 2, 3, 4, 5, 6. So every point of the hexagon is a carbon, but we're not going to leave our numbers. Don't leave your numbers. Okay, that's your final answer for A. All right, B. Well, if I look at this, I'm shown my condensed formula. So I know that this is not a cyclo. So how many carbons do I have? I have 1, 2, 3, 4 carbons. Me eat peanut butter. B is butane. Do a different color. Butane. So butane is 4 carbons. So I'm going to start 1, 2, 3, 4 carbons. Kind of looks like an N. Okay, make sure 1, 2, 3, 4. And that's all you have to do. Isn't it so nice and easy? All right, C. How many carbons do we have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8. Remember, like an octopus has 8 legs. So this is octane, right? Or if you're a Spider-Man fan, my son is a big Spider-Man fan. So you know he fights Dr. Octavius, and Doc Ock or Dr. Octavius has 8 little arms and stuff. Okay, so C, we want 8 carbons. So I'm going to start wherever I start with. That's my first carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8. And we got it. Okay. And remember, do not leave your, don't leave your numbers. Okay. Don't leave your numbers. All right. That one's for class, and that's it. All right. Talk to y'all later.